Here we're going to look at how you find the sample size you need to construct a confidence interval for P, a population proportion. So our margin of error is Z star times the square root of P hat Q hat over N. And we're going to solve that equation for N. That'll find the minimum sample size needed to estimate P. Okay, so to do that, the first step that I did was I divided each side by Z star. So you would have E over Z equals the square root of P hat Q hat over N. Then to get rid of the square root, I squared each side. Okay, so that's how I got to that first step. And then, if you cross multiply, so multiply the left side by N, you'd have N times E squared over Z squared, so you'd square the top and the bottom of the fraction, numerator and denominator. Okay, and then if you multiply each side by Z squared, and then divide by E squared, this is what you get. Now I'm not going to go through every step of that in detail, other than saying you can, if you have a formula sheet or formula card you can use, you can write this on your formula card. Okay, now if we don't know P hat or Q hat, you use 0.5 for both. And that'll allow us the largest possible error. So what that means is, when you look at multiplying P hat times Q hat, if P hat were say 0.2, and Q hat would have to be 0.8. When you multiply those, you get 0.16. If P hat was 0.3, then Q hat will be 0.7. Multiply those, you get 0.21. Okay, so if you keep on doing that, you'll notice the pattern is they get larger and larger. The product of P hat, Q hat gets larger and larger until you reach 0.5 times 0.5, which is 0.25. Okay, and then the rows, the columns flip-flop each other. So 0.6 times 0.4 will be 0.24, and then 0.7 and 0.3 will be 0.21, and so on. But you notice that this one right here is the largest. So if we don't know P hat and Q hat, we want to be as conservative as possible in our estimate. So using 0.25 here, which is 0.5 times 0.5 in the numerator, that'll allow us the largest value for N. Okay, because that's in the numerator. Okay, so if you read the question and it doesn't give you a sample proportion, then use 0.5 for P hat and Q hat. Okay, so here's the question. How many shoppers must be surveyed to construct a 95% confidence interval to find the proportion of shoppers who spend more than 1 hour in a shopping mall? We want the margin of error to be 3 percentage points. Okay, so we're trying to find how many shoppers must be surveyed, so we're trying to find N, and it's a confidence interval for a proportion. So that means we're using this formula. Okay, again, you have to remember that when you're doing a test or doing several questions and you don't know exactly what chapter they came from or what content they came from, you have to recognize that this is for a proportion rather than for a mean. Okay, because the mean, finding a sample size for a mean is different formula than for a proportion. Okay, so we're not given any sample statistics here, so we're going to use 0.5 for P hat and Q hat. The Z star value is 1.96 because it's a 95% confidence interval. And the margin of error, 0.03. So 3 percentage points will be 0.03 as a decimal. So you plug in your numbers into the formula. Okay, you end up getting 1,067.11. So we round up to the next whole number, 1,068. Okay, next one is very similar. I'll give you a minute to read that, and then I'm going to show you the answer. Okay, so I'm going to show you the answer now, so pause the video if you need to. Okay, so P hat is 110 over 165. Okay, so 110 out of 165. The complement of that, the Q hat, will be 55 out of 165. The way to look at that is if there's 110 successes, there's 55 failures out of the 165. Okay, and then when you go to your formula, plug it in, and you end up with 534.